But which one did I choose? Alright, ladies and gents, let's see a duel.
How are you handling everything? Is everything ready?
I am sure. If everything is ready, then it is time to move forward. The time has come. Camilla, are you sufficiently prepared?
I am ready.
It is time. Nothing we can do now but observe and hope for the best.
To your health.
And may the great serpent have mercy on your soul. What is this? What have you done to me, Amila?
I am affected as well, dear brother. I did not do this. I can hardly see you in front of me.
What the hell is this? What did you do? What is this? Sabotage!
This duel was an asinine idea, Borhal. We put a stop to it. There is no use for needless bloodshed at times like these. We must come together, not kill one another.
You traitors. You betray me. And then you lecture me.
Oh, enough of your grousing, Warhol. Your precious duel can wait. Are you truly so determined to kill me?
Enough of your taunting. This is not over.
I am counting on that.
Remove yourselves. We must rest. But know that you have only delayed the inevitable.
Thank the great serpent. You did it. The tranquilizer.
Hello,
will
welcome
save
in.
them both. Thank you for trusting me. What? From the tranquilizer? They will sleep a few days and be fine. I expect. They may suffer a bit, but it is a far better alternative to being stabbed to death. Nonsense. You've made the right choice. Their egos are bruised, but deep down they are both relieved. Come what may, we have narrowly avoided a bloodbath today. If they are stupid enough to try again, we will find another way to stop it. But I doubt that day will come. Me too. I want to thank you. You trusted me, and because of you, the brothers might have received if one of them had perished, but can you truly put a price on a human life? You are free to go.
I am a
May the
mercenary.
great serpent be with you. Always.
Bard's got a bard, baby. It's called the scientific method. You gotta do it. Bill Nye the Science Guy. So I'm not gonna do all this and there's the instruction behind it. Let's see, we're exploring the actual planet now. Oh, well,
To live inside M110.
I realized how loud that was gonna be earlier. Oh yeah, because I wanted to listen to it and have the thing up at the same time. City Silvers.
You would see Andromeda's vast, side-on galactic disk consume your sky at night. Just think of the historical, societal, and religious implications if early humans had seen something like this hanging in their ancient sky. Finally, there's Messier 33, aka the Triangulum Galaxy. It is the current third largest member of the local group, a dwarf spiral galaxy around 60,000 light-years in diameter. It is not known whether M33 is a true satellite of Andromeda. It may just be its own galaxy, which happens to be situated around 750,000 light-years beyond. But in any case, the two galaxies have definitely interacted within the last few billion years, and the data points to them interacting again in the future, with the 40 billion stars of the Triangulum Galaxy destined either to be absorbed into a new galaxy or to be banished out of the local group entirely. Finally, after millions of light years on this dark, lonely voyage, we arrive at the Andromeda Galaxy's outer edge. Once we've passed through the plasma halo, we reach the denser, extended stellar disk, made up of stars scattered by Andromeda's past collisions. Once we're through all of that, we finally reach the visible component of the galaxy, the barred spiral structure, rich in dust, gas, and metals, similar to the Milky Way. But unlike the Milky Way, Andromeda's spiral structure is more complicated, having been deformed by billions of years of gravitational interactions with the likes of the Triangulum Galaxy, among others. In 1998, the ESA's infrared telescope suggested that Andromeda may be transitioning into a ringed galaxy, as the dust in its body appears to be grouped into overlapping rings at various distances from the core. Studies in the years since, using NASA's Spitzer telescope, have shown two spiral arms which extend away from the central bar and beyond the rings, but they are fractured into 7 spiral segments, separated by junctions of enhanced hydrogen gas, where vigorous star formation is occurring. NGC 206 is one such region. Andromeda's largest star-forming cloud, situated at a boundary between two of its southwest spiral arms. At around 4,000 light-years in diameter, it is one of the largest clouds of its kind in the entire local group, and contains a cluster of more than 300 luminous blue supergiant stars with diameters dozens of times that of the Sun. And NGC 206 is not the only place where we find clusters in Andromeda. In fact, we've identified more than 460 globular clusters within its bounds, more than treble the number discovered in our own galaxy. The most significant of these clusters is Male 2. It is Andromeda's most massive known cluster, containing several million luminous stars of varying ages and metallicities. The mass, luminosity, and overall disparity in its stellar population implies that Male 2 may not be a true globular cluster, and may actually be the disrupted heart of a proto-galaxy. In a manner similar to M32, but on a smaller scale, the outer layers of Male 2 would...
Well, yes. Thank you for the painful reminder. Oh, love of my life. I'm Azar Dubas. My wife Shireen and I are scientists. We've been quite busy lately and are greatly amused. We put out a call for a research assistant, but with recent events, we haven't had much luck.
By which he means we haven't had any luck.
So, are you interested in a little field work? Gathering data, mostly. Nothing. Ideally, you'd be motivated by a fascination with the mysteries of science. But yes, it is paying work, assuming credits would suffice. My wife and I have been studying a recent and somewhat troubling thing. You see, the local wildlife has been dying, and we're not sure why. The remains show no signs of external injury or trauma, so we can rule out most of the usual causes.
Fighting for dominance or territory, predators, hunters, looking for sport, those sorts of things.
We began to see this phenomenon just after the accident in Nazca. We're convinced these events are linked, but the exact nature of the connection remains a mystery. An accurate assertion. This is where you come in. I need you to search for corpses of local wildlife and collect tissue samples. I'll give you a biosample collector that will extract and store the samples safely. Try to collect samples from different kinds of creatures. We want to cast a wide net. Return here when you've got them, and we'll begin the analysis. You're looking for creatures without an obvious cause of death. There should be no wounds, no blood, no sign of physical trauma. What we are searching for is an invisible killer. Off you go then, and note.
were stripped away and dissolved into the fields of Andromeda, but its galactic core managed to remain bound by its central intermediate mass black hole of 20,000 solar masses. And so now, these surviving stars cling to the black hole as it barrels around the galaxy, appearing as a surrogate globular cluster which hides the secrets of a richer past. Andromeda's stellar population seems broadly in line with the Milky Way's, containing old and young stars, clusters, nebulae, black holes, and perhaps life-supporting worlds around stars like the Sun. Unfortunately, M31 is much too distant for us to be able to hone in on the planetary systems of its stars. We can't even do that within our own galaxy. However, despite the odds, in 1999, scientists thought that they had detected indirect evidence for a planet within Andromeda, when a microlensing event was detected. Microlensing occurs when the light of a luminous source is bent very slightly as it travels towards Earth by the gravity of a planetary mass object. One possible explanation for this Andromeda-based microlensing signal, dubbed PA99N2, was that the light of a red giant star was being warped by a surrounding exoplanet with a mass 6 times that of Jupiter. Unfortunately, however, microlensing events often occur due to unpredictable chance alignments, and so it's unlikely that we'll ever be able to catch this same signal again to follow up on it. But even if not the result of an exoplanet, we can still say with relative certainty that Andromeda, like the Milky Way, is home to billions of planets orbiting its stars, many of which will be Sun-like and suitable for supporting Earth-like worlds. In addition to live stars, we've also found dead ones within Andromeda. Our search for X-ray sources within our neighbour has led to the discovery of dozens of black hole candidates, and possibly even neutron stars too. M31 is likely to be crawling with these deceased stellar cores, left behind by its older generations of stars. But the most significant black hole is, of course, the one that lies at the centre of the galaxy, in the place where we find one of Andromeda's most peculiar features. Its dense galactic core is split into 2 regions, classed as a double nucleus, with the 2 nuclei dubbed P1 and P2. P1 is the more luminous concentration of matter, but it is offset from the centre, thought to be a blanket of bright stars orbiting the inner nucleus. In contrast, the less luminous concentration P2 does lie at the centre, and contains Andromeda's supermassive black hole, which powers its galactic tide. The black hole is estimated to be more than 100 million times the mass of the Sun, significantly more massive than the Milky Way's central supermassive black hole, Sagittarius A star, which is only around 4 million solar masses. The reason for this disparity, like so many of Andromeda's other features, is likely the product of its past collisions. As Andromeda has swallowed other galaxies, these mergers have supplemented its central black hole with abundances of gas and matter. Thus, M31's black hole has consumed much more mass than Sagittarius A star over the course of its life, culminating in this overwhelmingly large beast, housed by the fractured compound galactic core. The journey to Andromeda is long, and at present untraversable for us humans. Even if we were able to escape the Milky Way's gravity, the time required to travel even 1 light year would vastly exceed the span of 1 lifetime. However, though we may not be able to get to Andromeda, we may not need to after all, as within a few billion years, Andromeda will come to us. When studying images of the galaxy, one striking aspect of Andromeda is its bluish tinge, but this is not the result of the natural colour of the galaxy's starlight. It is, in fact, being caused by a phenomenon known as blue shift, one of 2 types of Doppler shift. Doppler shift occurs when waves travelling towards an observer are warped by the motion of the object emitting them. Think ambulances and police car sirens. They sound different when approaching us to when they are moving away. This is because the oncoming sound waves are bunched up, while the ones trailing are stretched out. The same phenomenon applies to light travelling through space. If an object is moving away from us, its light will be shifted towards the red end of the spectrum, and the galaxy will become redshifted. Most galaxies in space are redshifted because the expansion of the universe is pushing them away over time. But by the same token, an object moving through space towards us will have its light waves compressed, causing them to appear blue. What this means is that Andromeda's aesthetic blue tint is indicative that it is heading right for us, at speeds of around 110 kilometers per second. The reason? Well, whilst the expansion of the universe separates most galaxies, Andromeda and the rest of the local group are all close enough to us to be attracted to the Milky Way's gravity. Thus, over the next several billion years, the contents of the local group will coalesce into a single object, starting with the head-on collision of the Milky Way and Andromeda. In the next 2 billion years, Andromeda will grow subtly in the night sky, creeping up in size until it becomes larger and brighter than the moon and every other night sky object. Within 3 billion years, it will occupy a considerable portion of our field of view, its light and gas extinguishing the view of the universe behind. Of course, barring some sort of miraculous engineering, the Earth will have long been rendered uninhabitable by the evolution of the Sun. But should anything further out in the solar system manage to survive this far into the future, they will see their sky tarnished and illuminated by a messy, asymmetric galaxy collision. In 4 billion years, the two galaxies will have crashed into each other, fundamentally deforming their spiral structures and scattering their gases. After the initial impact, the cores of the two galaxies will be brought back round again and again until they merge at the centre. With each iteration, hundreds of billions of stars will be rippled by gravity and sent cascading in all directions. Yet, despite the sheer quantity of stars involved, it's statistically unlikely that any two will actually collide, as the space between stars is incomparably larger than the stars themselves. That being said, stars will pass within range of one another, wreaking havoc on the orbits of their finely balanced planetary systems. The fate of the solar system ultimately depends on its position during and after the merger. Scientists have run scores of simulations to ascertain a final resting place for the Sun, but there's no clear consensus. On the one hand, the solar system could be ejected considerably further out, maybe into the bounds of Andromeda, or perhaps even kicked into intergalactic space altogether. Alternatively, the Sun may be flung inwards, towards the torrid heart of the new galaxy, where it may be ripped to shreds as it comes within range of the core. Around 7 billion years from now, the merger event will complete with the combining of each galaxy's nucleus, i.e., when its two black holes collide. These supermassive black holes will gradually begin to orbit one another. As they use their dynamic energy to catapult stars out of their way, their orbits will decay and they will sink towards the center. When they come within 1 light year of each other, they will start losing energy in the form of gravitational waves, generating immense tidal ripples which will be felt for billions of light years across space. Ultimately, these two black holes will merge at the center, creating a new supermassive black hole which binds the heart of the new galaxy. And after this, the final phase of the local group's evolution will have commenced. A new supergiant elliptical galaxy, unoriginally named Milkomeda. Galaxy collisions like this one are commonplace throughout the universe, and have played an important role in forming rich, diverse spiral galaxies suitable for habitable worlds like our own. But this cycle of collisions and mergers has a limit, and once the elliptical galaxy has taken shape, it will not change its morphology much from there. Instead, it will gradually absorb the remainder of its satellite galaxies over billions of years, including the Triangulum galaxy, which will likely orbit the new galaxy in the meantime. It will take more than 150 billion years before the last members of the local group have been consumed by this monster galaxy. But once they have, that will be it, forever. Long before that happens, star-forming gases within Andromeda and the Milky Way will be exhausted, and less will remain for Milkomeda to repopulate its stars when it finally forms. Thus, while the elliptical galaxy is projected to undergo a productive starburst phase of vigorous star formation, this phase will be brief and less fruitful than those we've seen in other elliptical galaxies. With no new stars to accompany old ones, the general stellar population of Milkomeda will age, an ever-increasing share of its stars progressing into the red giant phase, where they will either explode or evolve into white dwarfs. As this happens, the expansion of the universe will speed up, pushing galaxies beyond the local group far out of reach, ultimately destined to become undetectable. We will never encounter or even see another large galaxy again, and save for a few small minor mergers within the local group's remaining dwarf galaxies, Milkomeda will run out of rejuvenation mechanisms to keep itself replenished. The galaxy will stagnate and will start to die out. It will happen incredibly slowly, over tens of quadrillions of years in fact. But the galaxy's stars will eventually cool to a temperature of just 5 Kelvin, at which point they will no longer be hot enough to keep themselves luminous, and they will freeze into solid, impenetrable spheres of matter, their life-giving elements locked away inside. Bit by bit, our galaxy will become darker and dimmer, and once the last star has faded away, the story of Andromeda and the Milky Way will be over. Thankfully, humanity was born in the middle of this great galactic story, long after its chaotic opening, and long before its eternal depressing ending. Andromeda's story is more intertwined with the Milky Ways than the likes of Al-Sufi, Curtis, Shapley and Hubble could ever have imagined. And given that it's only been around 100 years since we realised that M31 was another galaxy, imagine what incredible knowledge our descendants will uncover in the next century. On the darkest of nights, free from the glow of the moon and the haze of light pollution, a stunning, striking formation can be seen imprinted upon the sky. Ancient African observers knew it as the backbone of the night, while Polynesian sailors thought it to be the jaws of a cloud-consuming shark. And ancient Greeks even believed it to be a stream of milk, spilled from the breast of the goddess Hera, which they called Gala, a prefix which would eventually give rise to the term galactic, and in the case of our galaxy, the Milky Way. Our galaxy is a giant which extends for hundreds of thousands of light years, yet its structure is more dynamic and evolving than we ever could have known. But thanks to the revelations of one particular mission, we're finally starting to unravel this great mystery by tracking the paths of stars to extrapolate our galaxy's past, revealing the history of the Milky Way. The Milky Way is an ancient, enormous barred spiral galaxy, constituting a peanut-like bar of densely packed stars at the core, surrounded by a series of swirling filaments of younger, hotter stars and gas. This spiral structure makes up the thin disk component of our galaxy, which stretches for just over 100,000 light years. But the true size of the Milky Way extends well beyond this visible component. Enveloping the thin spiral disk is a larger, thick disk concentration of more eccentric stars, rising for thousands of light years above and below the spirals. And even further beyond, we find the Milky Way's enormous galactic atmosphere, a diffuse halo bubble of stray stars, gas and plasma, along with the majority of its ancient clusters and satellite galaxies. In total, the Milky Way houses at least 100 billion stars, possibly as many as 500 billion, and about as many planets to go along with them. The Earth is one of those planets, lying 28,000 light years from the galactic nucleus, taking around 230 million years to complete a full orbit. In contrast, stars further away from the heart of the galaxy can take up